Welcome to the Tech and Space Leaders Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Johannes Gross. He is the founder and CEO of Planetary Utilities. Welcome to the show, Johannes.
Hi, thanks for having me.
Absolutely. It's so great to have you here today. Maybe you can start by giving us a little bit of background on yourself and Planetary Utilities.
Yes, so my background goes back to, I'm originally from Germany. That's where I went to school, aerospace engineering. And then I came to JPL in 2013-ish and worked there. I worked on a bunch of different missions, spectrometer. Actually, everything I worked on at JPL was a spectrometer mission. It is a spectrometer for the Subaru telescope in Hawaii, and then the Pixel instrument on the Mars rover, and the EMIT spectrometer that is currently on the International Space Station.
Wow, cool missions.
Yeah. So yeah, that's kind of my background at JPL, and then I went and launched Planetary Utilities a couple of years ago, and have been joined by some former JPLers as well. And yeah, that's what we're doing right now.
Excellent. Very exciting. Okay, so maybe give us your vision for Planetary Utilities. Where are you guys headed?
So Planetary Utilities is an infrastructure company. So the idea really is to build a planetary utility. So a utility company like your water company or your electricity company, but for space. So our goal is basically to enable the same level of utilities as if you want to build a house in your street. You already have a street, you have power, you have internet, and you have the sewer and the water pipes. So the same level of infrastructure and services should be available if you launch a space project. And that's kind of the vision behind Planetary Utilities, is to make it a lot easier to build space projects and implement space missions.
Great. Okay, so let's dig into it a little bit deeper. How does this actually work? So give us kind of, what are you actually building?
Yeah. So we have three products basically. And one is a hardware product where we're building a backbone. And the backbone is a structure that has interfaces and now modules that integrate onto these interfaces. So we're building base plates of modules, and they connect to the backbone. The backbone hosts all the networks. So first the mechanical, which is a structural connection connecting all the modules. Then the thermal, which is a pump fluid loop that connects the modules to a thermal system. And then power, that provides power to all the modules. And then all the data connections, basically the internet of the spacecraft.
Great.
And so we create this backbone and the base plates of these modules. And then our second product is a software. It's called StarForge, and it's a mission design language. So it's basically a language to specify space missions, but it's a programming language. So it's executable. You can specify your space mission, and then you can execute it in code. And so it integrates a lot of tools where you can simulate your orbits, you can simulate your thermal subsystem, you can simulate your power system. And so you can basically lay out your space mission in that software. And then the third aspect is Spaceproof, our testing suite. So here you can test the modules and make sure that your software model is correlated to what the reality is. And so with Spaceproof, what we want to achieve is basically we want to decouple the development process of these modules. And so you can develop them independently and then put space missions together made up from these modules.
Wow, that is really cool. Okay, so if I'm an engineer, I'm wanting to put a payload into space, I can take use one of these modules, or maybe one or more of these modules, and put it on board your main infrastructure, which you call that Starkit. Is that right?
Yes, correct. Yes, Starkit is our hardware platform.
Okay.
And yes, so since the subsystems are modules as well, it is really very flexible in what it can be, whether it has one power subsystem or multiple for high power applications. And so it can really change. But the standard size of a module is 1 cubic meter and 1 ton in mass and 1 kilowatt in power. So it's a large spacecraft, and it's a large platform for those modules. And so there's 7 modules on the backbone in one row, and then on both sides. So it's 14 modules to one kind of spacecraft, if you say. But then the backbones can also be connected to larger structures.
Oh, wow. That is amazing. So when we met before we had this call, you talked a little bit about an example of, a challenge that you saw, and really kind of what was the impetus that got you going on Planetary Utilities. Can you talk a little bit about what inspired you to found Planetary Utilities?
Yes. So it was a few things, actually. Like during my time at JPL, I was always looking at this beautiful machine that JPL is, and that just cranks out these amazing missions. And I was always like asking myself, how can we transfer this into the new space age, into this new paradigm where the launch costs are significantly lower? And so that really changes the whole structure of the industry in a way. And so EMIT, that project that built an instrument for the ISS, was kind of a part of the answer for me, because EMIT was that's where JPL is very efficient. If you build an instrument that is really the leading edge of what's possible, you need all the disciplines coming together to develop that new technology. And interfacing with the ISS was really interesting, because I learned a lot about how this interface to a existing system should look like, and what an engineer needs to really work with it. So one example, for instance, was that the transfer time from the Dragon trunk to our plug-in port on the ISS was 6 hours. And those 6 hours defined our thermal budget. And so in the end, from an ISS side, the Canada arm has specific requirements of how fast it can operate. And maybe it can do it a lot faster, but they have to give you a fixed interface. So the interface is, okay, 6 hours. And so we started working against that, and that completely drove our thermal design, because our instrument was cooling out and was basically dying of freezing death. And so we had to implement very expensive measures to circumvent that problem. And that made me realize that for really building an integrated system, every engineer that builds a module needs access to the whole system, and also to the robotics in a much more native way. And so our goal at Planetary Utilities is to bring these capabilities into the engineers' hands, and really give them the tools to test out hypotheses and try out things in software first, but then also with hardware test beds, and then in space.
Wow. Okay. So where are you in terms of the development of this solution?
So we have a software prototype that already shows really well how our software suite will operate, and what it will look like. We can generate photorealistic renderings of our spacecraft, but not just of one spacecraft, but of basically any combination, because it's all programmable, so to say. There's also simulations behind it where we can simulate the orbit and the subsystems of these spacecraft. So it's not just the view that's nice, but it's also the physics behind it that is very realistic. On the hardware side, we've been affected by the recent fire in Altadena. I don't know, I think you heard of it.
Yes.
And so our headquarters burned down, and so we're currently relocating to a new location, and starting to build up our manufacturing and our testing in that new location.
Wow. Gosh, we are so sorry to hear about that. That is incredible. But you did have a little bit of a sign of hope when you came to the location where everything was burned down, except what?
Yeah, it was actually, so the day before the fire, my colleague Robert and we kind of spontaneously decided to set up our prototype of our backbone. It was sitting in our warehouse, and right next to my house, and so we set it up on Monday night, and then on Tuesday the fire started, and when we got back there on Wednesday, it was our backbone that was the only thing that was left standing. everything around it was basically obliterated.
Oh my gosh.
Yeah.
Oh, that's so heartbreaking. Yeah, we always talk about how space takes a certain level of persistence, and this is kind of a whole new level of persistence that you guys are showing. And I saw your post about the fire, and it was honestly really inspiring that you still have this very strong desire to continue forward, and that the backbone was still standing was kind of this very inspiring symbol.
Yeah, there might be a deeper thread to be discovered in the future, where I think, the increasing temperature is the changes that our planet is undergoing are maybe linkable to that. And I think the space industry as a whole, and also us at Planetary Utilities, we're all intensely working to be a part of the solution to that. And I think space really is the domain in which the solution will exist, because that's where we can just gain more information about our planet, and also start to gain more leverage about the systems and its ecosystems.
Yeah, absolutely. So when do you plan to launch your first Starkit?
So our plan is to launch on Starship. Currently, the tentative launch date is late 2027, early 2028. And so we are basically, right now, we're developing the backbone and those base plates. And then once those are done, then we have a reliable interface that everybody can start implementing against. And so then we will bring on our partners that build subsystems and that build instruments and develop those spacecraft.
Great. Wow. That's like right around the corner.
It is, yeah.
That's very exciting. And so maybe you can tell us a little bit more about how kind of how you can use the modules, and how the payload engineers kind of will use those modules to launch their missions.
Yes. So the basic idea is that a module, or the entire system, is basically a hardware as a service system. So you don't buy a power module from us or from any vendor, you buy power in space. And so the ownership stays with the hardware manufacturer, which gives them the long-term interest to make things sustainable and to build things in a way that they last the longest possible time. But also through these interfaces, the spacecraft itself gets maintainable. And so a mission could use a part of a spacecraft, could use existing instruments and be a software-defined mission. But a mission could also have one module that it either procures from a vendor, or that somebody builds themselves. So for instance, if you want to try out a hardware in space and basically get it to TRL9 and space prove it, you could put it on a module, your interface, you get your power, you get your attitude control and communications through the interface. And so it's very simple for you to develop a space mission based on these modules.
Wow, that's amazing. Okay, so are modules still available for your next launch?
Yes, we're currently in the early talks with the first customers, and we're signing customers up for these modules for the first launch.
Great. So if somebody's interested in potentially having one of the modules, they can still potentially get on board that first launch.
Yes.
Excellent. Wow, that's very exciting. So I want to end with one last question, and that is about your one prediction about the future of space infrastructure.
I think the future of space infrastructure is mainly going to be driven by robotics and AI in the most optimistic sense. The way that I see it is that rockets like Starship, which are in a completely new class in terms of their economics, will basically pump hardware into the low Earth orbits, and then from there on, we will have a ecosystem of spacecraft that transfer to other orbits and then operate and exchange services and hardware and fuel and resources, basically. So I think there is going to be a big economic activity in space, and it's very exciting because it can be controlled from anywhere on the planet. And even as we see in the current situation, space has always been the unifying domain. We still have Russian and American astronauts on the ISS cooperating, and so I think space is really the domain where mankind can kind of hope to have a unified future where we work together.
Yeah, that's an inspiring future thought. I love that. So if somebody wanted to learn more about Planetary Utilities, what should they do?
Well, there's a little bit of information on the website, and we're going to bring out more as we can. We're going to launch our software as a beta. So if anybody's interested in becoming a beta user of our software, please reach out to me. We are onboarding the first customers right now. And then, just keep checking in on our website. And if you have interest in the system, reach out personally to me on LinkedIn or through our email. And I'm very excited for the future.
Excellent. Well, thank you so much for being here, and we wish you all the best in recovering from the fires and everything. We're so sorry to hear about that, and we really wish you all the best in overcoming that challenge.
Thank you.
Yeah, absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. You can learn more about GuideForce at guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.